how an object changes or moves with respect to the other. There are so many changes that you study in mathematics. Okay. There are so many changes in mathematics that we study using the idea of differentiation and integration. Now, under calculus, there are two types of calculus. The first one is differential calculus, and the second one is integral calculus. So, this differential calculus studies about how quantity changes with respect to another, whereas this integral or integration studies about, should I say, the area covered by a particular movement. The reverse process of this is this integration. You understand? So if you integrate a function, if you differentiate a function, that result button, if you integrate it back, you are going to get that function that you differentiated. So another name for this integration is called antiderivative. But that is not where we are going to base on today. Let us just focus on differentiation. Is this pen on paper or CBT? Okay, CBT. Okay, TCH. Alright, so under this differentiation, there are so many methods under differentiation. We have first principle. We have general rule. We have chain rule. We have product rule. We have quotient rule. We will have parametric equations or parametric, let me say parametric differentiation. We have implicit functions. And then we have applications. But before this parametric, add differentiation of 3 and logarithmic functions. Not only that, we equally have exponential functions that you can differentiate from using differentiation, and you can differentiate. Alright. These are the items that we are going to treat under differentiation. If you know all these, then you've covered all the concepts in a differentiation or differential calculus. And what is first principle? Okay, since you say that it is CBT, it is not a written based. That means we are going to ignore this for now, because they won't ask you to differentiate using first principle. All they know is for you to differentiate. You understand? So let us enter this general rule. Alright. If you have y equal to a function, let us say equal to f of x. If you differentiate both sides, you are going to have it that this is the y over the x equal to. If you equally differentiate this, you are going to have f prime x. That means another name for the y over the x is what? F prime x. Or you say derivative of f of x. Alright. So, have this question. If you have y equal to x squared, and you are told to find the y over the x, what do you do? For you to find the y over the x, what do you do? Okay, first of all, we should recognize or appreciate the fact that the concept of differentiation or differentiation, before you actually learn this differentiation, there is a topic that you should have mastered, and that topic is coordinate geometry. There are prerequisites to this differentiation. We have coordinate geometry. I don't know whether it is in the syllabus, is it? Coordinate geometry, where you have the equation of a straight line, and yes. So you have coordinate geometry, you have functions and then limits. Functions and limits. It is from this point you are going to get to you are going to get to a point where you will be told to find the gradient at a particular point, and that is the concept of this the y over the x. For instance, I don't know whether you guys think about the derivative of or the gradient of a straight line, where you'll be told to find what? Change in y over what? Change in x. Did you do it? On this vertical axis, you have what? Change in y. And on this horizontal axis, you have what? Change in x. That means your gradient m is equal to change in y over change in x. So this the y over the x is somehow related to this. But before you call this the y over the x, you are going to take a little approximation or limit. You are going to take the limit of this change in x as it approaches 0. And where we would have met it is this first principle. But because it is not pen on paper, we just bypass it. You understand? So for the general rule, for you to find the y over the x of this, the formula says that if you have y equal to x to the power of n, that in finding the y over the x, this n is going to come down. And you subtract 1 from the power. And if n comes down here, you have what? N times what? X to the power of what? N minus 1. What if you have a variable? Or sorry, what if you have a constant attached to this? Maybe you have 2x, or let me say ax raised to the power n. The differentiation is not going to affect this a. You understand? It will just be the y over the x equal to a, then find the derivative of this one. And if I find the derivative of this one, I'm going to have what? N times x raised to power n minus 1, which is what? A n x raised to power n minus 1. So in this case, what are we going to have? We will have it that the y over the x is equal to 2 will come down at b. So I have 2 times x raised to power 2 minus 1. 2 minus 1 is what? 1. Therefore, the y over the x equal to what? 2x. Okay. What of this? Y equal to x to the power of 33. Can you find the y over the x? Yes. So the y over the x becomes what? 33x raised to power 33 minus 1, which is what? 32. Beautiful. Automatically, the y over the x equals to 33x raised to power 33 minus 1, which is what? 32. Okay. What if you are given y equal to 4? Or let me say 1 over 4x to the power of 4. How do you find your the y over the x? The y over the x equal to 4, 1 over 4 by x. You are going to have the y over the x equal to what? 1 over 4. Bracket what? 4x raised to power. 4 minus 1 is what? 3, which is raised to power 3. What happens now? 4 we cancel 4, isn't it? So this will take care of this. I now have the y over the x equal to x to the power of 3. So this is minor cases of monomials. Can I get this one? Yes. Okay. You wrote it down, Abby? Yes. Okay. So if you have y equal to x raised to power 7 plus 6x raised to power 4 plus 5x raised to power 3 plus 6x squared, and you are told to find the y over x, what do you do? This is a term by term differentiation, and in differentiating, you differentiate one after the other. Just differentiate this one, keep it one side. Differentiate this one, keep it one side, differentiate, keep it one side, differentiate and do what? Keep it one side. At the end of the day, you collect everything. You understand? So it is not any there is nothing special about it. So for you to find, or for us to find out the y over the x, we are going to have what? 7 comes down, I have what? 7x raised to the power 6 plus what? This time is 24x raised to the power 3 plus 15x raised to the power 2 plus what? 12x. Is it hard?
No.
Okay. If you have y equal to x plus 2 times x minus 2 plus 1, and you are told to differentiate this. See, I want to tell you that you can differentiate so many functions, or you can differentiate one particular function using so many methods. If you check it and you think product rule is going to work, fine, use it. If you check it and chain rule is going to work, use it. If you only check it and general rule is going to work, you are free to do what? To use it. But in this case, since we are still dealing with general rule, that is 10 by 10 differentiation, what are we going to do? We are going to expand this first, are we?
Yes.
And then collect what? Like terms. So if I, excuse, hello? New master. Copy me above. Okay. So let us expand. I have y. You refill it within this one. There you refill it this one. So I now have what? Y equal to. Let me expand. Now this is difference of two squares.
Yes.
You know about difference of two squares, have you?
Yes.
Okay. So this thing becomes what? X squared minus what? Minus 4. X squared minus 2 squared, which is x squared minus 4. You are correct. So plus 1. Therefore, y is equal to x squared minus what? Minus 3. This is what we want to differentiate. And how do we do this? How do we do it? I remember telling you that you differentiate one after the what? Order. If you differentiate this one, keep it to one side. Equally differentiate this one and keep it to one side. Now, if you differentiate minus 3, what are you going to get? Beautiful. If you differentiate any constant, the answer becomes what? I remember telling you that the idea of differentiation studies about the rate of change of a particular quantity with respect to another. If you plot the graph, this is a graph now. This is a linear equation or linear function graph. And I want to find the change or the gradient of this. I just do this. Abi?
Yes.
My gradient becomes change in y over what? Change in x. But if it is a curve, maybe x squared plus any function, or maybe a curve that is not linear. If I have this, it will go like this. For me to find my dy over x, I am going to locate a point, or for me to find my gradient. There is something called tangent, a line that is tangent to this curve. It is the gradient of this curve that I am going to what? Evaluate. Sorry, the gradient of this tangent is something that I am going to evaluate. If I can get this, that means I can get the differential coefficient or maybe the gradient of this at a particular point. Now, what if you have y equal to 3, for instance? This 3 is a constant. If I plot the graph of this, I am going to have something like this. So this is my origin. This is minus 1, minus 2, 1, 2, minus 1, minus 2. I have 1 and then 2. What is the line of this thing? As in, if I want to plot the graph now, where is it going to be? Y is equal to 3. Okay, let me have my 3 here and then minus 3 here. Where is it going to be?
Yeah.
Y is equal to 3. Is it where? Check.
From the positive side.
Which positive side? Is it this side?
No.
This side?
Yes.
Okay, come and show me how the graph will be. Okay, let me ask you, is it this way or this way? This way.
No.
This way.
Yes.
That's not true. The graph is just, graph of y equal to 3. It's like this. You understand? Graph of y equal to negative 1 will go like this. Graph of y equal to minus 3 will go like this. But if it is graph of x equal to 1, see, we are looking for that point that y remains 3. At this point, y is 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 3. You understand? Even this point, so all this line now, the points that made this line, of course, the line is the distance between 2 points, isn't it? Yes. So all the points on this line, they are all what? 3. So my y equal to 3 is on this line. Now for me to find the change, are you with us? Huh? Okay. So for me to find the rate of change in this very graph, what do? I look for change in y divided by what? Change in x. So look at my change in x here. I know my change in x because I can compute the distance from here to here. Maybe this is 2 and this is, let me say, minus 3. So my change in x will be what? 2 minus 3, abi? Which is what? 5. But I cannot find change in y. I don't know if you are following me. Are you following? You are not following? Okay, I say that this is change in x now from here to here, isn't it? How can we get our change in y? Normally, it should have been, assuming it is like this, our change in y is changing the vertical axis now from this point to this point, and change in x is this point to this point, isn't it? But in this case, look at this point. It is that place that y started at a particular place and ended here, isn't it? That means change in y is equal to 0 at this point because there is no change at all in y, but there is a change in x, isn't it? Change in x is 5 now, moving from here to here. So change in x at this point is 5, change in y is 0. So for me to find my gradient change in y over change in x becomes what? 0 over 5. That means my gradient is what? 0. And that is why dy over the x of any constant. I just use 3 as a case study. You can use any other constant. You understand? You can use 5. If it is 5, then your graph will go like this. If it is 1, it will go like this, abi? So at this point now, the y over the x becomes what? 0. So I now have the y over the x equal to the differential coefficient of this is what? 2x minus what? 0. So I can draw. Okay, another one. Y is equal to x to the power of 10 plus 4x to the power of 8 plus 6x to the power of 6 plus 5x to the power of 4 all over x to the power of 6. But before this, I want us to solve a question. If you have this now, y is equal to x raised to power minus 3. How do you find the y over the x? Can you feel it? It becomes what? Okay, that means the y over the x is equal to, this will come down and be minus 3 x raised to power minus 3 minus 1, which is what? Minus 4. And I can rewrite this to be what?
Minus 3 over 1 over.
Exactly. It is minus 3 times 1 over what? X raised to power